This is the first lesson of grade 10. I'll be discussing this lesson in detail so that you can learn the stuff of this lesson clearly. Yes. We are going to calculate the circumference of this circle. It gives that the radius of the circle, that's 7 cm. How can you get the circumference of this circle? Circumference means, when it gives when it is met curves, then we talk about circumference, right? So circumference. So how do we get the circumference of this circle? The circumference of this circle can be taken, c equals to 2 pi r. C equals to 2 pi r. So 5 equals to 22 over 7. Generally that instead of 5 we substitute that 22 over 7, and r equals to 7 cm. Okay. Now this 7 and this 7 can be cancelled out, which means 7 is divided by 7, which is 1. So 2 times 22 is 44. The circumference of this circle is 44. So then from here to here distance, or this length, this curved part is 44 cm. So how do you get the we are going to get the in this grade especially this learned segment. This segment you've been taught last year, right? You know that it's able to use 2 pi r in terms of finding the circumference of a circle, 2 pi r. So the grade 10 staff started. Here firstly we talk about sectors of circles. So what's a sector of a circle? Here is a circle. This is the center of the circle. Radius, 2 radii you could see. Then this is an arc. Then this region specially we identify as a sector. Okay, here is a sector. So this segment also, this large segment, this part also is identified as a sector. This part also a sector. Here is a sector. Here is a sector. This part also a sector, large sector. When it compares with this one, with this sector, with this sector, this part. So here in this grade we are going to learn about the way of finding the arc length first, right? How can I find the arc length of this sector? Arc length means this part, right? Arc length means this part. If this is 30 degrees, if this is 7 cm, we could calculate the arc length of this sector. Arc length can be taken, arc length equals to 30 degrees over 360 degrees into 2 pi r. Why did I write here that 30 degrees? Here the reason, the angle at this center, is, this angle is 30. Therefore I written here that 30 degrees. The arc length, the length AB can be taken, arc length AB can be taken using this expression. Just to think of this type of one you've been given. This angle is 60 degrees. This is 14 cm. How do you calculate the arc length of this sector? So 60 over 360 degrees into 2 pi r. You are able to get the arc length using this one. If the angle is 60, then here we write as 60 over 360 degrees. The angle is 30 degrees, and we generally write as 30 over 360 degrees to 2 pi r. So you think of this one. The angle is 90. Now here 90. This is 7 cm. How do you get the arc length of this one? This arc length can be taken. Arc length can be taken, you know that 90 over 360 degrees into 2 phi r. So according to the given angle, which is at the center, then it changes the fraction that you write here. I mean here 90, then 90 over 360, 30 over 360, 60 over 360. So just I do believe that you got an idea about way of finding the arc length of a given sector. So right now let's calculate the arc length of this sector. This is 30 degrees. I will write this one as 60 degrees, right? This is 60 degrees. The arc length AB, this is O, center. Let's calculate the arc length of this sector. How do we calculate the arc length? The arc length of AB. Arc length of AB, according to the stuff that you learned previously, here 60 over 360 degrees times 2 phi r. Right now let's simplify this part. It gives that this is 7 cm. We are going to get the length of this part. Okay, so 60 over 360 degrees. How do you simplify really this one? You could simplify this 0 and this 0, which means both sides we divide using 10. So here, right now 6 is a multiple of 6. 6 times 1 is 6. 6 times 6 is 36. Therefore, both sides you could divide using 6. 6 upon 6 is 1. 36 upon 6 is 6. Okay, 6 divided by 6 is 1. Then 36 divided by 6 is then 6. So here the related fraction is 1 6. 1 6 times 2 times r 5 equals 22 over 7. You know that. So the value of r equals 7 cm. Right now we could simplify this expression. How do we simplify? Then 1/6, I will simplify this part here. 1/6 into 2 into 22 over 7 times 7. Let's simplify. So 7 upon 7 is 1. 7 upon 7 is 1. Right? So this 2 and this 6 also can be cancelled out. That's here 2, here 6. So 6 divided by 6. 6 is a multiple of 2 is a multiple of 2. 6 is a multiple of 2. Therefore, both sides can be divided by 2. So 2 upon 2 is 1. 6 upon 2 is 3. Right now you could see in the denominator 3 and 1. Here 1, 1, 22, 1. 1 into 1, 1. 1 into 22, 22. 22 into 1, 22. 22 over 3. 22 over 3 is, this can be divided, this fraction can be divided, that's 22 over 7. 22 over 7 means 22 divided by 3. Then in 22, how many 3 times? 3 times 7 is 21. Then 2 minus 1 is 1. Here you need to put 0, then simultaneously you need to write here decimal points, and also then 10 over 3 is 3. 10 times 3 times 3 is 9. 10 minus 9 1. Then here 0. Then again you should find multiples of 10, which is found in 10. Then 10 upon 3 is 3. 3 times 3 is 9. 10 minus 9 again 1. But anyway, as the answer we get 7.33. It's okay, right? To 2 places of decimals we get the answer. So the answer, the length of AB is 7.33, which means sorry, this arc length is 7.33. 7.33 is this arc length. But anyway, I have to tell you that, if you want to become an expert in this segment, really knowing that how to simplify these expressions properly is compulsory. Therefore, simplify properly these types of expressions. So as to become an expert, really, you need to do different sums should be done really. Okay. So this is the arc length of AB. Let's get the arc length of this sector. Okay. So here O, A, B. This is 14 cm, right? The radius 14 cm. Let's get this arc length. Arc length AB. Arc length of AB. How do we get the arc length of AB? So the angle is, here the angle is 90 degrees. Therefore, we write as 90 over 360 degrees into 2 phi r. 90 over 360 degrees into 2 phi r. So this 0 and 0 can be cancelled out. Then 9 upon 9 is 1 and 36 upon 9 is 4. So 1 time and 4 times. So 1/4 times 2 into 5 equals to 22 over 7 and also R equals 14 cm. Now you can simplify that. This 2 and this 4 can be cancelled out. That's 2 upon 2 is 1, 4 upon 2 is 2. And also you could see here, this 2 and this 22 also can be simplified more. The reason that 2 is a multiple of 2, 22 is a multiple of 2. Therefore, we could simplify that 2 upon 2 is 1, 22 upon 2 is 11. And also, this 7 and this 14 also can be cancelled out. That's 1 time, 2 times. So 1 here, 1 here, 1 here, 11 here 2. So 1 into 11 into 2. So 1 into 1 1 into 11 11, 11 into 2 22. So the answer is 22 cm, which means from here to here distance is, arc length is 22 cm. Let's calculate the arc length of this sector as well. This is 30 degrees. This radius is 10.5 cm. How do we get the arc length of PQ from here to here? We could get the arc length of PQ. How do we get the arc length of PQ? Really, previously we got the center angle was taken. So likewise, here also arc length of PQ can be taken. Then here 30 degrees over 360 degrees into 2 phi r. So let's simplify that. This 0 and this 0 can be cancelled out 1 time and 12 times. So 1 over 12. And also 2 into 5 equals 22 over 7 and R equals to 10.5. Really here I do not express that 10.5. The reason, if here is a decimal number, therefore I do not write as 10.5. Then how should we write this 10.5? This can be written as a fraction really. So this means that 10.5 means 10 and half. It is a mixed number. This can be kept as an improper fraction. Then 2 times 10 is 20. 20 plus 1 is 21. So 21 over 2. So instead of this 10.5, we could write as 21 over 2. 21 over 2. This is the best method, best way of simplifying this type of decimal number. When it is given a decimal number as a radius, then you could write it as, that radius as a fraction. So now this can be simplified that this 7 and this 21 can be simplified. That 7 times 3 is 21. 7 times 3 is 21. So let's simplify that 1 time and 3 times. And also you could see here this 2 and this 2 also can be cancelled out. So one time and one time. And also you could see this 3 and this 4 also can be simplified. So once, although you simplify this, this 3, after simplifying you written here this 3, that's okay. This 3 again you could simplify with this 12. So 1 time and 4 times. What else? You could see here this 22, this 4. This 22 and this 4 can be cancelled out. That's 22 is a multiple of 2. Therefore 11 times this 4 divided by 2 is 4 of 2 is 2. So here 1, here 1, here 11, here 1, 2, 1, 1. So in the numerator you would see here 11. Therefore 11 over 2. Then here 2 into 1, 2, 2 into 1, 2. So 11 over 2 is 5.5. So the answer is, this arc length is 5.5. Then from here to here 5.5. I'll clean this part. This means you could pause the video and you could check this part, this clean part again. So this means, then from here to here 5.5. This arc length is 5.5 cm. Okay, the arc length is 5.5 cm. Now I will teach you that then how to calculate this type of so far we learned that how to get the arc length of a given sector. Right now I will teach you, now just you learn that how to get the perimeter of a sector, right? Of a sector. You think that, yes, what should be the perimeter of this one, of this sector? We've taken that this from here to here 5.5, and if this is 10.5, then this segment also that 10.5. How do we get the perimeter of this sector? The perimeter means that then you could get the perimeter of this part. If this is x, if this is y, you could get the perimeter that adding these values. You know the concept, you know the idea of getting perimeter of a plane figure. So here you could get the perimeter that adding these values are x plus y. So x plus x 2x, then here y. Likewise, just bear in mind this one. Likewise, you are able to get the perimeter of this sector adding these values. Here 10.5, here 10.5, here 10.5. This value plus this value plus this value. So we could get the perimeter of this sector adding these values. 10.5 plus 10.5, and also how to add here 5.5 as well. So 10.5 is 21. 10.5 is 21. Here 21, and again 21.0 plus 5.5. 0 plus 5, 1 plus 5, 6. So the answer is 26.5. So the perimeter of this sector is 26.5 cm. Bear in mind, when you simplify these addition, when you subtract, when you multiply, when you simplify, when you add, just do clearly so that you can get the proper answer. Okay, don't forget, when it comes to maths, simplifications needed. You need to do simplifications clearly. Otherwise, you won't be able to get the proper answers. So, let's get the, the perimeter of this sector. Perimeter of this sector. Let's get. Okay, so here. This is 30 degrees, the angle is 30 degrees. We are going to get the perimeter really. So this is, this is, I will give you this, the radius as a decimal number. I will give you 10.5 I gave you. So I'll give you 3.5 here. I'll give you 3.5 here, 3.5 cm, 3.5 cm. Here O, here A, here B. Right? Let's get the perimeter of this sector. to be taken the perimeter of this sector, first thing is you how to get the arc length of this sector. That's the first thing. The question is you how to get the perimeter of this sector. In order to get the perimeter of this sector, first of all, you how to get the arc length of this sector. Arc length from here to here. So arc length can be taken that the angle is 30 degrees. 30 degrees over 360 degrees into 2 phi r. 30 degrees over 360 degrees into 2 phi r. So this 0 and this 0 we could simplify, and also 3 is a multiple of 3, as well as you could see 3 is a, 0 and 0, 3 is a multiple of 3, 36 is a multiple of 3. So simplify that 1 time and 12 times. Therefore here 1 over 12 times 2 into 5 equals 22 over 7, and also it has given here that the radius of the sector that 3.5. 3.5 means 3.5. 3.5 means 3.5. 2 times 6 plus 1, 7. This type of one was done previously. So instead of 3.5, we could write that 7.7 over 2. Right now, we could simplify these fractions. So this 2 and this 2 can be cancelled out. That's 1 time, and this 7 and this 7 also can be cancelled out. That's 1 time, as well as you could see here 12, here 22. So this 12 and this 22 can be cancelled out. 12 is a multiple of 2, 22 is a multiple of 2. Therefore, we could simplify that then 6 times and 11 times. So that's okay. Now 1 into 1, 1 into 11, 11. 11 over 6. 11 over 6 means this is, this 11 divided by 6. So 11 divided by 6. In 11, how many 6 times 1? 6 times 1, 6. 11 minus 6 is 5. Then here 0. Then how many 6 times in 50? 6 times 8, 48. Then here 2. Then again 2. Then 6 times 3, 18. So the answer here is 1.83 cm. So the arc length is 1.83 cm. Right now we could get the circumference of this perimeter of this sector. How do we get the perimeter of this sector? So the perimeter of this sector, then from here to here also 3.5. We could add these values. These values can be added. Here 3.5. So the perimeter can be taken that, these values let's add. Perimeter of this sector. So 3.5 plus this 1.83. So yes, then 3.5 plus 3.5. What is really 3.5 plus 3.5? 3.5 plus 3.5 is 7, but here anyway 1.83. These values let's add. 10 plus 5 plus 5, 10 plus 5, 8, 18. 5 plus 5, 10 plus 8, 18. Remain this 1. Then 3 plus 1, 4 plus 3, 7 plus 1, 8. So the answer is, answer is 8.83 cm, which means this is a perimeter of this sector. So I do believe that, I do think that you are able to, you can get the perimeter of a given sector. So, and also I should teach you the given statement in your textbook properly. The common way which uses to get the arc length as well as perimeter of a sector. So, so far when it comes to these questions, we use the angle which is given in the sector. I will give you this angle as theta. This is theta. Okay, we could get, then it gives the radius as this is radius, right? OAB. We could get the arc length of this sector. Arc length can be taken of this sector you know that. How do you get the arc length here? Theta over 360 degrees into 2 phi r, right? Then really right now you can identify, you can realize this expression. I do think that's properly. Then when the angle was changed, then if the angle is 60, then here we write the 60 over 360 degrees in terms of getting the arc length. If the angle is 30, then here we write 30. So here is a common form, common way of getting the arc length of a given sector. So you think of that, then if this is R, then this one also R. Perimeter also can be taken of a given sector using this one. So, here R. So R plus R. And also this value also should be added. So, this value means theta over 360 degrees into 2 phi R. 2 phi r. So theta over 360 degrees into 2 phi r uses to get the arc length of a given sector. So you know that here 1r plus 1r, 2r plus theta over 360 degrees into 2 phi r. Okay, this is used to get the perimeter of a given sector.